Hey there, my name is Kenny. I'm the developer advocate at the Stacks Foundation, where I focus on developer education, developer outreach, and just generally making sure that developers have a great time building Bitcoin apps using Stacks and Clarity. Today what I want to do is I want to go through how to use the Hiro platform to create a super basic DeFi smart contract that's going to be a borrowing and lending protocol called Lagoon. There's a few different goals that I have with the tutorial today. One is to give you an introduction to the Hiro platform. The second is to give you an introduction to Clarity and specifically how to use it to create something like a basic DeFi application. And then the third is to introduce you to the concept of sBTC and the mock sBTC token that I've created called sBTC Starter that'll help you be able to get up and running with sBTC before the production version is out later this year. So we're going to go ahead and get started. And the first thing that I want to do is right here. I've got the Hiro platform open. The URL is just platform.hiro.so. So if you go here, you'll be presented first with a sign up screen, but then as soon as you sign in, you'll go here to the new project screen. So I'm going to go ahead and create a new project. For this project, we're going to do blank. You can see that Hiro Platform's got several example projects here that you can use, but we're just going to do a blank project for this one. And while this is loading, we're going to go over here and go to stx.is/sBTC starter, and this is going to be that starter repo that I was talking about with the mock sBTC token. So I want to spend a couple minutes talking about this, and then we'll jump into creating the Clarity smart contract over in the Hiro platform. So I've got this starter repo here, and really what this is designed to do is this is designed to allow you to start experimenting with sBTC now before the production version comes out. If you're not familiar with sBTC, I highly recommend going to sbtc.tech to learn more about it and what it is. But at a high level, it's essentially a decentralized, permissionless, trust-minimized two-way peg to allow us to bridge Bitcoin between the Bitcoin L1 and the Stacks L2. And once sBTC is done and out, most of the complexity of that bridge process is going to be happening behind the scenes. Again, go to sbtc.tech to learn more about how that's actually going to work if you're interested. But as an application developer, really all you're going to have to do is interact with the Clarity smart contract, because sBTC is going to be implemented as a standard SIP10 fungible token on the Stacks chain. There's actually going to be a Clarity contract that's going to correspond to it, and you're going to be able to use it just like you would be able to use any other fungible token. The reason I created the sample repo is because basically what I've done here is I've cloned the actual sBTC Clarity contract, and I've just modified a couple lines to make it so that it's not verifying the actual on-chain Bitcoin transaction occurred. So if we go up here into contracts and go into the sBTC contract, I won't go through this line by line. I do recommend taking a look at it on your own time though to kind of see how sBTC is going to work. But you can see here it's just a normal SIP10 token. And then down here we have this mint function. And this is where we actually mint our sBTC. You can see I've got these two lines commented out. In the production version of sBTC, how this will work is that whenever you deposit your Bitcoin in order to mint sBTC, the sBTC protocol is going to call this contract, which is first going to verify that that transaction where you deposited your Bitcoin on the L1 side of things actually occurred. And if it did, it's going to mint you the sBTC. But since this is a mock version, I've gone ahead and commented those lines out so that we can just mint our sBTC on demand for testing purposes. If you were to create a real Clarity smart contract using this when the production sBTC came out, all you'd have to do is change the contract that you were calling in your Clarity contract to the real sBTC contract and switch it from the mock one, and then you'd be up and running. So this is what we're going to use today. So what I'm going to do first is I'm going to copy this. We're going to go back to the Hiro platform, and now we can see our project set up here. So really quickly, on the left hand sidebar, we can see our contracts. We can open up a web editor or a local editor if we want to. Local editor will actually allow us to use the Hiro platform as our development environment, but still be able to use our local VS Code setup if we want to. And what the platform is going to do is it's going to give us an interactive cloud-based IDE to basically do all of our Stacks development. So we have DevNet here, so we can set up a local mocknet environment for our Stacks projects. Once we write our contracts, we'll actually be able to call them directly from in here to test them out. We can deploy them from in here. And then we can also set up chain hooks and interact with the API. We won't be doing those today, but you can do that from here as well. So the first thing I want to do, create a new contract, sBTC, enter. I'm actually going to create a couple other contracts right now as well. Another contract that we'll need, that I'll explain in just a second, is we will need a Clarity Bitcoin mini. Hit enter there. And then the final contract we need is going to be our actual borrowing and lending protocol, which is going to be called Lagoon. So the first thing I want to do is I want to go into sBTC. I want to add in what I just had here. And so this is our actual sBTC token. And you'll notice here that we're implementing this SIP10 trait. And so there's one thing that I have to do if I want this to work correctly before we move on, and I need to make sure that our project is actually including this sBTC trait. So I'm going to get this line from the GitHub repo. If you go into the GitHub repo right here, go to sBTC starter, and go to the clarinet.toml file, this is the part that I'm going to be putting into the project on the Hiro Platform, just to tell Clarinet, which is what Hiro Platform uses behind the scenes, that we need to use this in order for our project to run. So I'm going to go ahead and go back to the project page. Oops. See, I want to open project files, sorry. Open in web editor. And this is cool because this is actually going to open up an instance of VS Code in the browser for our project. So I'm going to go into the clarinet.toml. There's currently an empty requirements array, so I'm going to delete that. And I'm just going to add in a new section, the project requirements with that trait right there. That's going to save automatically. And then we can go back to the platform. And this will take a second, but this error should resolve in just a second. That's what this error actually is it's saying that we have an undefined trait here. So if we go back in, let's make sure that's actually the error that's showing. This is because we have not added the functions to our Clarity Bitcoin mini library yet. So what is this Clarity Bitcoin mini library for? If we go down here to our mint function, what you'll see is that this is calling a verify transaction ID exists on burn chain function. If we go find that down here, this is going to be a private or a read-only function, and this is going to call that Clarity Bitcoin mini library and pass in a transaction ID. And what's going to happen is this Clarity Bitcoin mini library and this was transaction ID mined function, this is actually going to be directly reading the Bitcoin state and the Bitcoin chain itself using that get burn block info function that's built into Clarity. And it's going to be verifying that the transaction we're using to attempt to deposit our sBTC actually works. So because this is a requirement in the contract, we need to include it here too. We won't actually be using it directly in this project, but we're going to include it to make sure everything works. This is another very interesting contract that I'd recommend digging into. There's a lot of low-level stuff here with how we actually can interact with the Bitcoin chain via Clarity. Interesting to get into, but we're not going to cover it here today. But that makes our sBTC error go away. So now that we've done that, let's go ahead and let's write our Lagoon contract. We're going to start by first defining some of our data. We're going to define a few different things here. First, we're going to define a map called deposits. This is going to have a key of principal, and then it's going to have a value of an amount. And this is just a map that's going to keep track of all of the deposits that we have in our Lagoon protocol. Loans is very simple. This is going to keep track of all of the loans that have been taken out of our protocol. And this is going to be an amount and also a last interaction block. And this is how we're actually going to determine how much interest is owed on this loan, is how much time has passed between when the loan was taken out versus now. And then we're going to multiply that by an interest rate that we actually have right here. And we're just going to hard code this as 10, which is going to represent 10%. Quick caveat here, this is obviously not production level code. It's not been audited. This is just for example purposes only. If you would like to use this as like a starter for creating your own borrowing and lending application, you can, but this is very, very bare bones, not at all production ready. So make sure that you actually do some research into how to properly create borrowing and lending protocols, get it audited, test it, all that stuff. The other two pieces of data here, we have total deposits where we're just tracking the total number of deposits that we have, and then the pool reserve, and this is going to be actually correspond to how much funds the pool has in it. And so we'll get into that a little bit later when we go into the functions. And then we're just creating some error codes here for different error scenarios we can run into. So the first function we're going to be creating is the deposit function. We're going to put that right here. So this right here is there's a check checker built into Clarinet, and all this does is the check checker just checks to see if we have checked any data that were arguments that we're passing in via the user. In this case, we want to tell it that we want to allow unchecked data because we want the user to be able to pass in what they want here. We don't need to check for a specific value. We'll make sure that the values passed conform to what they need to in other functions, but in this one with the deposit function, there's no restriction on what they can pass in for the amount other than it has to be a uint. So we can pass that flag there to tell the check checker that that's okay. So we're defining this public function here with a single argument of uint, and that's going to be the amount that the user wants to deposit. We're going to jump into a let block, and remember the first section of a let block here is where we're going to define our context variables for the rest of the function. So we're defining a single context variable here called current balance, and that's going to get the amount that corresponds to the transaction sender's key in this deposits map that we have up here. If it's not found, it's just going to set that to 0 for the deposit amount for the current balance. Once we have that current balance set, the next thing we're going to do is we're going to call the transfer function of the sBTC. So remember, as an application developer in Clarity, all you're really going to have to be doing is interacting with sBTC as you would any other fungible token. 99% of the time, that means you're going to be calling the transfer function, because you're going to be transferring sBTC back and forth from users to contracts. So we're going to do the amount from the transaction sender to the contract. And this as contract keyword right here, this is how we can basically pass in the contract's address into this function. So that's how we do that, is right here. This none, there's a optional argument in the sBTC transfer function for a memo. We don't need to worry about that here, so we're just passing in none. Assuming that succeeds, next thing we're going to do is we're going to update that deposit map with the amount that we just deposited in. So if we have a current balance, we're just going to add the amount to that to update the map, and then we're going to update our total deposits and return OK true. So relatively simple for the deposit function. Next up, we are going to implement our borrow function. So we can put that right here. Again, we're passing in an amount here. We've got several context variables to set here in this first chunk of our let block. So the first thing is that we want to find our user deposit, similar to how we did up here with the current balance. But we're going to get the amount of the deposits the user, the transaction sender specifically, currently has in the protocol. If they don't, we're going to default to 0. And then we're going to get the amount that they are allowed to borrow. So in this protocol, it's an over-collateralized borrowing and lending protocol, so the user is basically allowed to borrow up to half of what they have deposited in the protocol. And so that's what this is doing right here. Current loan details. This is going to check to see what current loans the user has in the protocol right now. And so this is going to pull that. It's going to default to 0 again if we don't have anything there, but it's going to get that item from the loans map that corresponds to the key of the transaction sender, and then that's going to set our loan details. And then we're going to calculate the accrued interest. And so that's going to require us adding another function. This one's going to be a private function. Add that right here at the bottom. And so what is this calculate accrued interest function doing? One, it's taking in a principal, but it's a type of uint. So when we say principal here, we're not talking about a stack's address. We're not talking about a principal data type. We're talking about a principal in the context of a loan of finance. So the principal is going to be the amount that the user has taken out as a loan, excluding the interest. That's what we mean by principal here. And then we're going to check a start block, and this is when the loan was actually taken out. We're going to set a couple context variables. We're going to do elapsed blocks, which is going to calculate the difference between when the loan was taken out and now, the current block height. And then we're going to use that to calculate the interest. So to calculate the interest, what we're going to do is we're going to take that principal amount. We're going to multiply that by the loan interest rate and the elapsed blocks. Then we're going to take that number. We're going to divide it by 10,000. The reason we have to do it this way is because there's no decimals in Clarity, so our 10% interest rate has to be represented by just the whole number 10, and so we're dividing it by this so that we can get the proper amount of interest that they actually owe. And then we're going to make sure that this is not the first block of the loan, because that would mean they don't have any interest. If it is, we're going to return 0. Otherwise, we're going to return that amount of calculated interest that we have here. And that's what's going to be set right here in this accrued interest context variable. Next, what we're going to do is we're just going to add that accrued interest to the current loan details to get the total amount that they have due. And then we're going to create a new loan variable, which is going to add up both of those for their new total loan amount. Next thing we're going to do is make sure that they are not trying to borrow more than they are allowed to. So remember, we have that 50% rule where you can borrow up to 50% of what you have deposited. So we're going to make sure they're not trying to take out more than that here. And if they are, it's going to return an error. And then we're going to call the transfer function of the sBTC function again, but this time we're going to transfer it from the contract to the transaction sender, assuming that that assert statement passed. And then we're just going to update that loan with the last interaction block, which is when this loan was updated, which is going to reset that interest calculation, and with the amount of the new loan. And we're going to return OK true there. Next up, we've got borrow. And now we're going to define a public function called repay. And this is going to allow borrowers to repay their loans. Again, we take in an amount, very similar selection of context variables here. We're going to get the current loan, the accrued interest, and the total due. We're going to make sure that the user is not trying to put in more than they owe because we don't want them to overpay. So if they are, we're going to return an error. Then we're going to attempt to call that sBTC transfer function again with that amount. This time it's going to be the transaction sender sending it to the contract. Assuming that succeeds, we're then going to update the loan with the total due minus the amount that they paid here. And then again, we're going to set that last interaction block to make sure we reset that calculated accrued interest. And then we're going to add in the accrued interest into that pool reserve. And so that's what's going to be the, that interest is going to be the yield that our depositors can claim based on the proportion of funds that they have deposited into the protocol. And that's going to be the last thing that we implement right here, is going to be that claim yield function. So right here, we don't need to take in any arguments here because we're just going to use the transaction sender. But we're going to set to the first context variable of user deposit. This is just going to figure out, like we've done already, how much the user actually has deposited into the protocol. And then it's going to use that plus the pool reserve plus the total amount deposited in order to basically get the proportion of the pool reserve that's owed to this person that has deposited into the protocol. And so that's what we're going to use here to get that yield amount. And then we're going to call the sBTC transfer function from the contract to the user with that yield amount. And then we're going to set the new pool reserve to basically subtract that yield amount out. So now we have the new pool reserve, and we are going to return true. So that's our basic borrowing and lending protocol built in Clarity. And the goal here was really to give you an introduction to Clarity, but also to give you an introduction to Clarity in the specific context of how can I actually build out something that's at least a starting point for something real. And so what you can do here is you can use this as a starting point to build out your own borrowing and lending protocol. Go and research other DeFi protocols, different borrowing and lending, see what they do. This is obviously extremely minimal, extremely bare bones. There's lots of missing functions here, hasn't been audited. There's a lot of different things that need to happen here to turn this into a production level Clarity contract, but it does give you a starting point for one, learning how to use the Hiro platform, a little bit of an introduction to Clarity so you can see how it might be used in a little bit more of a real world context instead of the typical hello world examples. And so now what I want to finish up with is I just want to show you how we can actually test this out. And there's two ways we can do it. One is that we could use DevNet. And what DevNet's going to do is going to start up a local version of the blockchain running in our browser within the Hiro platform, and that'll actually mine blocks one by one. The simpler way to do it is just to use the console, and that's what I'm going to use here. You can do either one. It's really personal preference. DevNet is pretty cool because what you can actually do if you have your DevNet running is you can go inline to the functions here, and you can hit call deposit. If you start DevNet here, it'll show all the functions and all the different arguments that you can pass in, and then you can actually see those being mined and happening in the blocks. So it's a little bit more of a direct one-to-one comparison for user testing than the console would be. But we're going to go ahead and do the console for this one just for simplicity's sake. All right, we've got our clarinet TOML file right here, and what I want to actually do is I want to open up a new terminal session here. So we'll do create new terminal. Put this up a little bit. Move the camera up here. Let's zoom in just a little so you can see that better. Okay, so the first thing we need to do is remember that we're using sBTC to do all this. So the first thing we need to do is we need to actually mint that sBTC to our user. And when we start Clarinet console, it's going to do a couple different things. It's going to set us up with a bunch of default addresses with some default stacks balance. And it's also going to get all of our contracts deployed, and we can see those here. Here's the sBTC contract, here's our Lagoon contract. So the first thing we want to do is we want to mint our sBTC. And the way that we can do that is we can run contract call to our sBTC function right here. So contract call sBTC mint. We are minting a whole Bitcoin, or count these zeros. Yeah, looks like one whole Bitcoin, so 100 million sBTC tokens, because an sBTC individual token will correspond to a Satoshi, which is the smallest divisible unit of Bitcoin. And we're going to mint those to our deployer contract. And I actually want to switch this up and mint these to a different address, because I want them to be tied to one of the other addresses here. So we're going to go ahead and get rid of all this. I am going to replace it with this one, and this is going to correspond to that second address here. This first address is going to correspond to our deployer, but I want it to be one of our user wallets, so we're going to do that one there. We'll call that mint function. Gives us an OK true. And then what we want to do is we want to call one of the helper functions in the Clarinet console called set transaction sender, and that's going to set our transaction sender to the address that we just minted our sBTC to. So now we've switched the context of our console. We're now calling it from this new transaction. And now what we can do is we can call the deposit function in our Lagoon contract so that we can deposit some sBTC into there. We'll call that. Okay, true. We're all good there. Next, we want to go ahead and borrow from that. And remember, we have to pass in a smaller amount, less than half of what we did. We're doing much less than that here. We're going to call borrow there. It's going to give us OK true, so that one worked. Now what I want to do is I'm going to go ahead and advance the chain tip using another utility function so that we can test out that yield generation. So we're going to advance the chain tip by 200 blocks. And now I'm going to call this new function get amount owed. And that one is going to not work because we did not actually write that. So what we're going to do is we're going to head back here. And we're going to go ahead and add that function right down here at the bottom. And that function is going to look like this. And all this is going to do is use those same context variables to get that total amount due, and it's just going to return that. So we've got that there. Now if I go back here, what I'm going to have to do is actually restart the console. And I don't want you to have to watch me copy and paste all of that over again, so I'm going to speed run through this part real quick. So now we're at that same spot where we've advanced the chain tip after we've borrowed, so we can generate that yield, and we're going to go ahead and see how much we actually owe. And that's going to return this amount of 12,000, and that's our principal plus the interest that we've generated as a result of passing through those 200 blocks. So now we can see how much we owe completely. And what we can do here now is we can repay a part of it. So let's say we want to pay all but 100 sats of that. We're going to hit repay there. That's going to return OK true. And now what I want to do is I want to switch the transaction sender back to this other contract. And now what we'll need to do is we want to deposit. Actually, first we need to mint the sBTC to this new contract, and then we're going to deposit into the protocol as this new principal. So we'll mint to them. And then we're going to go ahead and deposit from here as this one. Perfect. So now we've got an amount here that we've deposited. And now what we can do is, again, from the context of this original that we have here, we are going to go ahead and claim our yield. and that's going to return OK true, and we can see that the amount of 1,000 has been transferred. And the reason is because there's 1,000 in that reserve pool, and outside of the person that has actually made the loan, we're the only person that has contributed to that pool reserve, and so we get 100% of that yield. If there were to be more people involved in that, then we would get a smaller amount of that yield. So that is how that simple borrowing and lending protocol works. Got an introduction to the Hiro platform, got an introduction to Clarity, got a little bit of a taste of how we can build like a borrowing and lending protocol like that. So what I would encourage you to do now is keep exploring sBTC, look at that sBTC contract, go out and see what other kinds of DeFi protocols exist, both in and outside of the stack system, see where the gaps are, use this as a starting point in a learning project. Definitely check out the docs at docs.stacks.co. Definitely check out the courses on LearnWeb3 and the Stacks developer degree at learnweb3.io. So that's it for this one. Thanks for watching. See you next time.